Coverage of warm water on the equator is expanding. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, April 23rd.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when videos are posted, typically on Sunday evenings. Also, you can donate. Hit the special thanks button down below. Make a small contribution. We're working on getting a new server. We're almost there. All right, it's time to get to work. And as Jake Marlowe said, all killer, no filler. All right, let's do it. Looking at significant wave heights for the North Pacific Ocean, not a whole lot is going on. Little area seas in the 12-foot range off of the Pacific Northwest, and some other disturbed area of weather north of Hawaii, but not generating any meaningful swell. And then some more weather off Kamchatka. We're getting pretty close to the end of the season, if we're not there already, and we're going to start focusing down south pretty soon. Let's start by looking at current conditions. We'll look at the buoys, starting up in Northern California. Point Reyes buoy, number 029. We're looking at all the energy that's hitting that buoy, anywhere from up to 33.3 second, really long period energy, which there is none, the whole way down to 5 second period, just pure wind swell. Something that is, or it's actually wind chop. Real swell starts somewhere around 7 seconds, and by that I mean just wind swell. And then ground swells right around 13 seconds. Yeah, there's a little bump at 16 seconds, pretty much insignificant, all buried with much more energy in the 6 to 7 second period range. Putting that all together, primary swell, 7 feet at 6.3 seconds from 317 degrees. That would make surf about 4.5 feet on the face, and that's about what it is. Next up, we'll go down to the northern end of Southern California, buoy 46053, East Santa Barbara buoy. Again, there's nothing but really just wind chop, wind swell mixture. Primary swell, 5.4 feet at 6.6 seconds from 263 degrees. That would be surfing about the waist high or a little bit higher, something like that. Going down to the southern end of Southern California, buoy 191 Point Loma South. Really pretty much the same picture, just all wind swell. Looking at it, 4.2 feet at 8.4 seconds from 292 degrees. Again, about waist high, and that's about what the surf is. And then we go over to the Hawaiian Islands. The Waimea Bay buoy is down, but we can go to Kauai and at least get a rough idea of what's happening. Honolulu buoy, number 202. There is actually some swell here, 13-second period, and then the standard trade wind generated east wind swell below that. Primary swell, 3.7 feet at 13.2 seconds from 292 degrees. That's surf about 4.9 foot Hawaiian. There are definitely waves in the overhead category, 2 feet overhead, something like that. It's been like that all day on north-facing shores, so actually some surf, at least somewhere in the Pacific. We're going to look and see where that swell came from. We're going back to Thursday, 06Z Thursday. It's almost Wednesday night, the 20th of April. Little gale developed here off the Kuril Islands. That's Japan, Kuril Islands, Aleutian Islands up there, U.S. West Coast, Hawaii right there. And this is really where the swell generated or originated from that is currently hitting Hawaii. This little area of 18-foot seas on Thursday, and it continued in about the 18-foot range. Then still the same thing going into Friday. It fell south, and just for a moment, Friday night kind of blew up a little bit, and seas were 22.8 feet right down here. Those are the highest seas over this entire domain. Right there, 22-foot seas, aimed reasonably well at the Hawaiian Islands. Then by Saturday, that system all faded out. Also notice there was a little bit of fetch up here in the Gulf of Alaska, but nothing. You saw it on the buoys, a little bump of energy trying to come into California, but really nothing of any interest, all buried in local wind swell. And yes, we are finally going to start looking south because there's something to look at. On Tuesday, the 18th of April, southeast of New Zealand, a little gale developed here with 30-foot seas lifting and building. Let's see, got right about there is when it peaked out. 12Z on Wednesday, the 19th of April, 39-foot seas, and then started pushing off to the north. By Wednesday evening, those seas were down to 35 feet and fading from there. That said, you can still see lingering the swell front right here into Friday and Saturday, and that swell is pushing north, bound for California the later part of the week. And for the most part, in fact, let's go back and look at this real quick relative to Hawaii. Hawaii is at about 158 west. This system was south of Hawaii, but it was all going due east. It didn't start lifting northeast till it passed the Hawaiian Islands. So the expectation is little to no swell for the Hawaiian Islands. So what's coming for the next week? We're going to start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough. We see it right there. That really is the left. This is what created that swell that's currently hitting Hawaii. What a trough does is it falls down like that. That creates a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface and generate seas. Seas, as they radiate away from the fetch area, groom themselves out, and eventually turn into swell. And of course, swell, when it hits your beach, turns into surf. So swell from this trough, when it was more back here, is already hitting the Hawaiian Islands, likely to fade over the next day or two. We also see a bit of a trough trying to organize directly over Kamchatka. Let's see what that does. Well, not a whole lot. So we get into Tuesday. The jet, now the interesting part is the jet is to become consolidated all south of the Aleutians and with decent amount of winds associated with it. And then as we get into Tuesday and Wednesday, look at this, another more organized trough being fed by 140 knot winds sets up over the dateline. That trough builds with right somewhere around there, about 160, 170 knot winds feeding into it on Thursday, the 27th of April. Likely supporting gale development, and then digging deeper but getting pinched off as we get into Wednesday and Friday and then Saturday. So maybe some sort of swell will result from that. And then even as we get into Saturday, the jet still consolidated, pushing almost the whole way across the Pacific. Little bit of a lift here, that'd be a ridge here. Ridges do the exact opposite. They create a clockwise flow aloft and down the ocean surface. That's the hallmark of high pressure. And relative to California, maybe that would be a good thing. Dry things out even more. I mean, things are actually pretty nice right now in Northern California. Springtime is happening. Flowers are blooming in the hills. Beautiful time to get out and go take a walk. And it looks like that pattern will continue as we get into next weekend. You can just see the ridge holding right here. But no real energy in the jet route a week. I was looking at this going, well, maybe, hopefully, but this trough here, there's no real wind energy associated with it. The other thing is, because we are in spring moving towards summer now, the jet doesn't have as much power or as much ability to drive the weather down at the surface as it does more in February. So the momentum is fading here, and as we saw, moving to the southern hemi. So looks like the North Pacific is getting ready to go to sleep. Let's take a look at surface level pressure, surface level winds. We know there's a trough right here, and there is the low pressure. What is that, like 1,008 millibars? Not even hardly low pressure, north of Hawaii, and the expectation is that will just sort of fade out. We know there's a trough forecast setting up here around Wednesday. We see little bits of low pressure. What is that, 18 to 20 foot seas over a tiny area, but sort of moving, not really getting any good traction. We go into Thursday, Friday, the system tries to, the trough is here trying to dig something out. The low associated with it here looked better this morning on the 12Z run of the model. Now, pretty much nothing. A secondary fetch behind that as we get into Saturday, really doing nothing. Oh, there we go. Then the low finally blows up. Here we go. Roll this back on, there we go. Starting Saturday, we get some 30 to 35 knot winds, and there we go, 40 to 45 knot. But by that time, the low is lifting north. All the fetch is aimed at, we'll say, British Columbia northward. So maybe something, but that's almost a week out. And then here we are, a week out. Now look at this. Theoretically, I don't believe this, 40-knot winds. That looks like a real swell-producing system. The trough that was supposedly feeding it was very weak. Seems like the upper level portion of this model and the lower level model are maybe not talking to each other very well. This looks way stronger than it should be given the upper level scenario. So let's go look at the effect of those winds on the ocean surface. Right now, really, we need seas at least 18 feet, and that's being generous, so that'd be in the yellow. We don't see anything like that, and we're just going to sort of blast through this, just looking for anything. There's, maybe 17 or 16 foot seas on Wednesday. We know a little bit of low pressure there. There is, yes, some 20-foot seas off the Krills, but they're all pushing to the north. Nothing going to result from that. Then we know there's another little thing going to happen up here on Saturday. There we go. 20-foot seas, actually 21.2 feet, and then building to 25 feet, and then 27 feet. But notice the fetch is all lifting north. If you want it aimed down here, the fetch really needs to be falling to the southeast. So all this swell, you can see the leading edge of the swell here. Pretty much bound for, we'll give it Vancouver Island northward, maybe even some sideband swell into Oregon, but probably not a whole lot. And then here's this fake storm forecast for the dateline with 20-foot seas, way overhyped, and we don't believe any of that right now. And then we're also going to look down south. Okay, we're not going to do the whole Jetstream thing and surface analysis because it's just too much for most people. But a bit of low pressure is supposed to be pushing under New Zealand on Tuesday. That's not so much the issue or the thing we're interested in. But come Thursday, the low pressure tries to reorganize, generating 28-foot seas east of New Zealand, and theoretically building a little bit with 30. Here, I'll pull this away. 30-foot seas right there, 31.8-foot seas. This would be on Thursday night, the 27th, and then continuing in some fashion into Friday at 28 to 30 feet. And it's not like these seas are particularly high or anything, but one, they're going to last a long time into Saturday, and they're going to be well far to the north, meaning that the closer they are, U.S. mainland's up here and Hawaii's up off the top of the chart, but the further north this is, then the less distance the resulting swell has to travel, less decay, and the better odds for meaningful swell hitting anywhere from Peru on up into the U.S. West Coast and Hawaii. Then going out a little bit beyond that, another system is forecast pushing under New Zealand, but it's falling southeast or due east, and we're not really expecting anything from it. But it looks like more of a pattern is setting up in the southern hemi, and our focus will be turning there maybe as early as next week, while the North Pacific pretty much goes to sleep. Quick look at local wind projections for California and Hawaii. Today, Sunday, trades for the Hawaiian Islands, pretty clean. Northwest winds in control. This is just the incessant, there's your La Nina and enhanced high pressure just sitting right up along the coast, creating a gradient with weaker low pressure inland and just this steady northwest wind pattern, creating a lot of upwelling along the California coast. And much colder temperatures. Everyone's complaining about it, myself included. Hopefully we won't have too much more of this. So we get into Monday, 20-25 knot winds along the north and central California coast. Southern California projected. It looks like sort of a mixed bag on wind, some sort of southerly flow associated with this low pressure here north of the islands. So we get into Tuesday, 20-25 knot northwest winds north of Point Conception. A light wind regime for the Hawaiian Islands. Not really trades, but not bad. Northwest winds finally break up a little bit, limited to maybe Cape Mendocino on Wednesday with a lighter flow. Maybe if we get lucky an eddy flow, that south wind, and we'd really like to see that because the south winds, if they develop, that really tamps down the upwelling pattern, and it's not necessarily going to draw warm water up from the south, but it will allow the water to not upwell at all, and then things start warming up. Northeast trades for the Hawaiian Islands. So we get into Thursday, just a lighter northwest flow for California, light and variable winds for the Hawaiian Islands. Friday, Now you get a hint maybe of a little bit of a south flow here for Northern California, and for Central California, just light northwest winds. Trades for the Hawaiian Islands and quite light. Saturday, light northwest flow for California. Trades for Hawaii. And then Sunday, it looks like here comes high pressure in the northwest wind machine yet again, with stronger trades for the Hawaiian Islands at 15 knots. And at that point, you see where we're going, right back into another mega upwelling event for California and stronger trades for the Hawaiian Islands. So we're in spring. We will be. Wouldn't expect this upwelling pattern to probably wrap up until mid to late May, something like that, maybe even later, depending on how much longer the last little bits of La Nina hang on over the East Pacific. We're not even going to look at precipitation or snow. The short of it is no precipitation, no snow forecast for the higher elevations of the Sierra. Winter is over. We're in full-time spring skiing mode now. Not a bad thing. Corn snow is great. Almost as fun as powder. All right, but let's go look at the surf forecast for Half Moon Bay area, Northern California. Yeah, a little bit of bump of swell here on Monday, Tuesday. That's all wind swell. So this is projected surf height. You can see heights generally very small. The swell size, 7 feet, and the swell period down here at 7 to 8 seconds. And then building a little bit, but really period still in the just wind swell category. Then as we get into, here we go, into Friday, Thursday, Friday, Saturday sort of thing, the period jumps up 15, 16, 17 seconds. Swell size small. This is that southern hemi swell generated last week. 1.7 or 1.8 feet at 16 seconds. That gets you surf in the waist high sort of range, maybe chest high at top spot. So potential for some surf. Looking at Santa Barbara, really nothing, no real surf. Whatever there is now, that'll fade out as we get into Monday. All pure wind swell. Winds light in the area. Just looking at swell sizes, 1.5 feet, a foot, something like that. Not much wind swell wraps around Point Conception. San Diego getting a little bit of the wind swell wrapping in around under the Channel Islands, but more so down in the southern part of Southern California, some swell, 2.5 feet, we'll say waist high, something like that, from the building. Here you go, your 16-second period swell, southern hemi swell, 1.7 feet, 1.5 feet, and you see the wind swell sort of mixed in there too. So you know where to go. Get some waves, a little bit of southern hemi swell, and hopefully more behind that. North shore of Oahu, swell continues into Monday and Tuesday in the 5-foot range, then slowly dribbling down from there. Pure swell, 4.5, maybe 5 feet at 12 seconds, fading to 11, fading to 10, fading out. And then a little bit of reinforcing wind swell beyond that, but things definitely settling down for the season on the North Shore. Let's go take a look long-term. What's going on with the MJO, the Madden Julian Oscillation, and the El Nino Southern Oscillation. These two oscillations are the major influencers of weather, both in the northern and the southern hemisphere, and so we follow them. They give us a view out anywhere from a month to a year from now. All right, we're going to start by looking for signs of the active phase of the MJO. The MJO, the Madden Julian Oscillation, has two flavors, active and inactive phase. The active phase is the one that we're most interested in. The MJO rotates from west to east around the planet. Active phase on one side of the planet, inactive phase on the other, roughly speaking. It's when the active phase moves over the Pacific, what it does is, one, it imparts energy to the jet stream, be it either on the northern hemi or the southern hemi, and if you have a stronger jet stream, then you have a higher potential for generating storms and therefore surf. Also, when the active phase moves over the West Pacific, it can dampen, if not out-and-out reverse trade winds. It's a low-pressure system, and low-pressure systems on the equator, one, help fuel the development of hurricanes, but also can dampen trade winds. those dampened trade winds, as the active phase moves from west to east across the Pacific, it will drag that dampened trade wind pattern with it. That in turn can take warm water that's in the far west Pacific, start moving it off to the east, not on the ocean surface, but in the form of a Kelvin wave, a ball of warm water that follows, that goes not on the equator, under the equator, following the thermocline. We'll get into that in a minute. And it takes about 3 months for that ball of warm water to eventually reach Ecuador, impacting the coast there, erupting to the surface. If you have multiple active phases of the MJO and they're strong enough, you get multiple Kelvin waves, and that in turn can help usher in El Nino. And that's exactly where we've been and where a lot of our energy and excitement has been about the past couple of months, because we have had now 3 solid active phases of the MJO traverse the Pacific, producing 3 Kelvin waves. One has already impacted Ecuador. The second is poised to impact, and a third we think is developing in the far west Pacific. So all eyes should be focused on the MJO if you're doing any long-term forecasting. All right, so we're looking for signs of the active phase of the MJO. The MJO, again, it can dampen trade winds. So we can look at data from the TAO buoy array, series of buoys strung across the equator. This is the East Pacific here, West Pacific here. That's New Guinea right there. There is the equator. The date line's right there. We're just looking at the arrows. The arrows show wind direction. They show winds pretty strong out of the east. In the East Pacific, pretty strong out of the east in the West Pacific, and pretty strong out of the east over what we call the Kelvin wave generation area, or the West Pacific. This is where, when the active phase is over here, and if the trade winds reverse or die, then takes warm water that's here, start pushing it east. But it's not the actual wind speeds that matter, it's the anomaly, the difference from normal for this time of year. So these strong easterly winds, well, we're looking here and go, well, wait, there's actually a couple of like westerly looking arrows suggesting that trades are weaker, if not reversing, in the East Pacific. Same deal over the Central Pacific. They're neutral to maybe slightly westerly. And then in the Kelvin wave generation area, for sure they're a little bit westerly here, but then starting to build out of the east here. To me, that would sound like the active phase of the MJO is somewhere here over the Central Pacific, making its way this way, and perhaps the inactive phase is starting to show up in the West Pacific. What have winds been doing the past 5 days? Well, we can look at this. This is 850 millibar zonal wind anomalies. That's up at about 4,700 feet. That's pretty good proximity for what's going on at the ocean surface. And here is, this just past 5 days, South America here, Central America, Hawaii right up in there, the equator right there, dateline right there, and New Guinea right there. So it's this area that we're interested, because this is where the Kelvin wave generation area, we call it that. This is where, if you have west anomalies here, they're pumping energy into the jet stream, and they can also be helping to create a Kelvin wave. So 15th of April, the oranges, and you can see the little arrows. Maybe it's a little small on YouTube, but you get the general idea. Westerly anomalies. They continued on the 16th, started fading some on the 17th, still present on the 18th, and there, but it looks like the pattern from here to here, shifting more to the east. 850 millibar zonal wind anomaly forecast for the next week. Okay, this is what's happened in the past. The oranges and yellows, westerly anomalies. Dateline runs right up the middle. Far west Pacific starts at about 125 east, so right there. And one's eye would just look at this and go, well, westerly anomalies. There's easterly anomalies, but that's a solid bout of westerly anomalies that have been in the West Pacific since pretty much the whole month of April, and just today pretty much fading out. This looks like the active phase of the MJO, and maybe strong enough to generate a Kelvin wave. Now here's the forecast starting. It's just this area from the far west Pacific to just over the date line that really matters. That's the Kelvin wave generation area. We see this pattern setting up with easterly anomalies filling half the Kelvin wave generation area, and very weak, if not neutral, west anomalies over the western half of the Kelvin wave generation area. So sort of a mixed bag forecast for the next week. Let's go look further out. Next up, outgoing long-wave radiation charts. Another way. This is just measuring cloud cover or forecasting cloud cover. The reds are less cloud cover. They call it outgoing long wave radiation. More sunlight outgoing from the planet, basically bouncing off the ocean surface. Where the blues are negative anomalies, meaning less sunlight bouncing off the ocean surface, one can infer that to mean cloudy. So oranges and reds, cloud-free, that'd be the inactive phase of the MJO. The blues, cloudy skies, low pressure, the active phase of the MJO. And let's get ourselves oriented. That's Africa right there. South America, Central America, Hawaii, New Guinea there, Australia, equator right there, dateline right there. Sure looks like the inactive phase of the MJO is over the maritime continent. And then on the other side of the planet, somewhere Africa, trying to work its way into the Indian Ocean, the active phase of the MJO. 5 days from now, and this is from the statistic model, inactive phase over the Kelvin wave generation area. So this is pretty much a window saying not great for surf production. That said, we know there is some surf forecast. Continuing 10 day, or we'll say 10 days from now, but then notice the active phase building in the Indian Ocean and starting to seep into the Pacific 2 weeks from now. That's per the statistic model. The dynamic model says, yeah, the inactive phase thing is all true. After that, we go into a neutral phase, and then some flavor of a weak active phase shows up 2 weeks from now. So you can see the difference between the two models on their fourth panel here. Reality typically is somewhere in between the two, but that's still 2 weeks from now. I don't trust a model even a week out, so we'll have to see how this all plays out. Next up, phase diagrams, just a drill down of the same two models, the statistic model here, the dynamic model here. All right, now, how do you read this? Well, the MJO moves from west to east around the equator, from the Indian Ocean, over the maritime continent, that's like Bali, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. Where the heavy dot is where the active phase is today. So this looks like it's over Africa. The further the dot is away from the circle, the stronger it is. You can see where it's been. So back in April, well, 1st, 2nd, 3rd, the whole way through most of the month, the first part of April, it was over the West and East Pacific and being pretty distant away from the circle, say modestly strong, but now it's over Africa. The forecast has it somewhere in the Indian Ocean, one member going the whole way into the maritime continent 2 weeks from now. The dynamic model suggests the active phase going, well, we'll see here, over the maritime continent and exceedingly weak, but it looks like it's poised to move into the Pacific after that. So we'll see. Let's go dig a little deeper. Next up, the upper level model, and this is again a statistic-based model. Okay, this just shows areas favorable for precipitation. We've talked about the MJO clouds, talked about its effect on trade winds. Now we'll just look at the effect of potential for precipitation, which is some variation on clouds. All right, this goes out 40 days, South America there, Central America there, New Guinea there, equator right there, dateline right there. The oranges are dry air, not favorable for precipitation. One could say the inactive phase of the MJO. And there's your active phase, smack over Africa. Okay, so we go down here way inactive till about May 8th, something like that. So what's that? That's 2 weeks from now, something like that, with the active phase starting to make headway into the Pacific, then fully into the West Pacific as we get into mid-May, and then continuing on across the Pacific through the early part of June. So May looks like maybe a good window for swell production. Next up, the CFS model going out a month. Again, this is the east-west component of the wind. Blues, easterly anomalies, reds and yellows, westerly anomalies. And also here, now this chart gives you the solid contour is the active phase of the MJO. And you can see here is a big fat active phase that traverses, the Pacific starts 125 east, so right there, dateline right there. California is about 120, 117, something like that. So you can see back in February, big active phase, lots of westerly anomalies, produced a Kelvin wave for sure that is pushing across the Pacific, and then that active phase faded out. Then we had an inactive phase in March that produced easterly anomalies. Now here's our current active phase, or it's all but gone as of yesterday, but it produced westerly anomalies and maybe yet another Kelvin wave. Now here's the forecast for the next month. Notice no solid contours, no black solid contours, no black dotted contours. These are like equatorial Rossby waves or something like that really don't have pretty minor influence. But you see, we're looking just at the wind pattern here in the far west Pacific. We see pretty much a neutral pattern here for the next week. Then a week after that, we see a little bout of easterly anomalies in the Kelvin wave generation area. Then the week after that, westerly anomalies take over for pretty much the rest of the month, and pretty strong on the dateline, even in the absence of any clear MJO signal, be it active or inactive. So this is kind of what some of the longer range models have been hinting at too, just sort of this steady state westerly anomaly pattern set up. That's exactly what we want, because that'll just act as a pump and pump warm water from the West Pacific and the Maritime Continent the whole way across the Pacific for months. And then finally, the CFS model going out 3 months. Past performance down here, the forecast up here. Again, as we've talked before, this is the east-west component of the wind. Easterly anomalies are blue. Westerly anomalies are red and orange. You can see just this huge contrast between what was, and this is back in January and early part of February, easterly anomalies totally in control. But look at this. Then you see this yellow thing making it the whole way across, the whole way around the planet for that matter. That was the active phase of the MJO that produced Kelvin wave number 2, which is just roaring its way across the Pacific. Then here's our current active phase, is my guess, active phase and the westerly anomalies associated with it. And then we have a little bit of a dead period here for literally a week. And then westerly anomalies are to take over, holding on the dateline, and just lock steady for the foreseeable future. So let's overlay the MJO, see where we're at. Dotted contours in active phase, solid contours the active phase. So here we are back in January or February, massive active phase of the MJO. Here was our last inactive phase. Here's the current active phase, all but gone, maybe one more day left of it. And then we get into this inactive phase pattern weekly, but notice westerly anomalies holding the whole way into June, when then we get a legit active phase of the MJO, and that synced with this just the steady base state of westerly anomalies get stronger and stronger, building to strong status. Now, what's really going on? Let's overlay the low-pass filter here. This is the El Nino La Nina indicator, the high-pressure, low-pressure bias. Dotted contour, high pressure, solid contour, low pressure. Dateline is right here. Now, going back in January, you see there was this dotted contour, high pressure, in control of the Pacific. This is the La Nina signal that's been in place, and it's been like this for 3 years. And then somewhere in the March time frame, notice it really started easing off to the east. And as of right now, is out of the Kelvin wave generation area. 170 west is the start of the Kelvin wave generation area. So it's east of there. But notice, California's at 120 west. Why do we have perpetual high pressure off the California coast and constant upwelling and this just cold weather pattern? Well, it's all due to, this is what we call the remnants of La Nina, sitting due south. This is just on the equator now, due south of California. But the net effect is it supports high pressure both north and south of the equator. So that's what's driving it. And it'll be that way till the seasonal change just basically stomps on it, or until something like this comes up. When's that? That's the early part of June. I'm hoping we don't have cold water till June, but maybe we will. Anyway, the solid contour, the El Nino bias, the low pressure bias, you can see it easing steadily east. Where is it at today? Almost filling the Kelvin wave generation area. Give it another 2 weeks, it will be properly filling the Kelvin wave generation area. That explains the presence of these westerly anomalies, even with the inactive phase of the MJO in control. This high-low pressure bias pretty much trumps everything else. It is the major determiner of what happens in the Pacific, or for that matter, anywhere in the planet. So we follow it closely. And then you can see 1, 2, 3. I think last week we had 4. Oh, there's the fourth contour up there, starting to build solidly in June and July, and then El Nino really getting its momentum going. All right, enough MJO discussion. Let's talk about what's going on down in the ocean. Subsurface temperature anomalies, or actual temperatures. This is the West Pacific here, East Pacific here. This is data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. These X's are the anchor lines on those buoys. The individual X's are sensors on the anchor line. Okay, those sensors pick up subsurface water temperatures. The thermocline, we talked about that. Basically, this 24-degree thermocline, everything above this line is warmer than 24 degrees centigrade. That's pretty warm. Everything below it, pretty cold. What happens when you get the active phase of the MJ over here? It creates westerly anomalies, takes warm water, you can see it right there, starts pushing it east, but not on the surface. It falls down, hits the thermocline, and then follows it across the Pacific. As it starts getting into the East Pacific, the thermocline rises, concentrating the warm water in a smaller space. It gets warmer and warmer and warmer, then hits Ecuador, erupts to the surface, then gets caught by the trades and starts getting dragged across the equator. This is when we said if you have successive active phases of the MJO that create successive Kelvin waves, and then things really start cooking off of Ecuador and the Galapagos, and then the atmosphere, you get more evaporation, the atmosphere responds in turn, changes the whole planet's circulation, and that is basically the essence of El Nino. All right, so here's our 29-degree isotherm. Warm, this was back somewhere around 178 last week. I think it's at 180 this week, so it's easing off. The 28-degree isotherm was 157 or 158, now to 155 west, and with pockets of it, you can see this the whole way across, so things are warming up. 26-degree and the 24-degree isotherm just keep getting thicker, deeper the whole way across the Pacific. All indications of a warming Eastern Pacific. But it is not the means, it's the anomalies. Difference from normal for this time of year. The clear thermocline Kelvin wave superhighway is in effect. It starts about 150 meters down. You have 4-degree centigrade above normal temperatures here, with 2-degree anomalies the whole way across the Pacific, another pocket here. So this is Kelvin wave number 1 that's been impacting for months now, still gurgling there. Kelvin wave number 2 is somewhere in between. We think this is the start of Kelvin wave number 3 here. But there is another way to look at this. Now, this approach uses a totally different technology. We'll get into that in a second, but let's just look at the data. Cooking 4.5-degree, almost 5 degrees centigrade anomalies in the far East Pacific here. Kelvin wave number 1. And this is actually getting cooler compared to what it was a couple of weeks ago. But then here is a whole nother Kelvin wave right here, the leading edge of it, right at 100 west today, just about poised to start reinforcing, backfilling in for Kelvin wave number 2. Again, successive active phases of the MJO creating successive Kelvin waves. It takes 3 months for warm water to travel from here the whole way here. That's thousands upon thousands of miles. So this Kelvin wave here started, well, if this is April, we go back 3 months. What's that? January to February to March to April. So somewhere in mid-January, which was when this Kelvin wave number 1, is actually Kelvin wave number 2. Kelvin wave back here was back in December. But so when it first started percolating in the West Pacific. So our current Kelvin wave that's just fading out now has 3 months for itself to make its way across the Pacific. So you can see this guy's been in flight for months, poised to impact, and yet the last active phase of the MJ, we think this is the leading edge of its respective Kelvin wave right now. And so this is what, mid-April to May, June, July. It won't make it over here till July. So what you see, though, is you get this active phase, a pulse of water coming from it. It takes 3 months to make it across, and they just start stacking up, and it turns into a machine and a river of warm water coming across the Pacific. This is the sea level anomaly. This is satellite data, and this is really what drives that image right there. Different technology, not using sensors. What this is about is a satellite, polar orbiting satellite, rotates north to south around the planet, just doing like this, and the Earth rotates underneath it. And what you do is you get contiguous swaths of the Pacific, and it takes about a week to get a complete mapping of every square inch of water on the Earth's surface. So this is about a week behind what the Buoy data says. But what you do is you strip out the waves, the wind waves, the tides, and you just examine the sphere of the ocean. Is it higher or lower than normal? If it's higher than normal, well, one can assume there's warm water at depth. Warm water expands, that'll create a bump on the ocean surface. Likewise, cold water contracts, it'll create a divot on the ocean surface. And all we care about is 5 degrees north and south of the equator, because that's where the Kelvin waves travel. If they can't deviate because of Coriolis forces and a bunch of other physics, but basically it just tracks right. Oh, and let's Chile, Peru, Central America, Hawaii up there. There's the date line. There's the equator. New Guinea is right there. So you see positive anomalies, 5 centimeters, not very much. I don't know what's 5 centimeters, something like that. But you can see it the whole way across the Pacific, where all this was in negative territory during La Nina. And you can see the expanse of those warm waters creeping north and creeping south from Kelvin, the first baby Kelvin wave, then Kelvin wave number 2. This is probably the leading edge of Kelvin. In fact, let's go look. 100 west, boom, right there. That's the leading edge of Kelvin wave number 2, getting ready to slam in. And then Kelvin wave number 3, you can't even see it, but it's all gurgling around, either slide and warm water sliding under, but most of it's sliding over top of New Guinea, getting ready to get our next Kelvin wave going. Upper ocean heat anomalies. Now we're going back in time. This is the West Pacific here, East Pacific here, and this is just temperatures in the upper 300 meters of the ocean surface over time. Okay, so we did have a little active phase of the MJO and a Kelvin wave back in June of last year, but it barely made it to the East Pacific, and then there was just this massive upwelling response after that, high pressure, no Kelvin waves, no active phases of the MJO. Then back in December, we got like a teaser active phase and little baby Kelvin wave. I didn't even number that one. But then in the January, February, you can see there's Kelvin wave, the real Kelvin wave number 1, making it across the Pacific, erupting solidly since mid-March, something like that. Now here is Kelvin wave number 2. Its leading edge somewhere right around there, and it's just going to backfill right in to this one. And then Kelvin wave number 3 is percolating somewhere around here. At some point, it becomes difficult to number the Kelvin waves and actually pick them out because it just turns into a river of warm water. Sea surface temperature anomalies. All right, we've talked the MJO, and that's sort of the atmosphere and the atmosphere's effect on the ocean surface. Then we've talked subsurface temperatures. That's the Kelvin wave machine. But at the end of the day, it's what's happening on the ocean surface that really matters. The Kelvin waves are sliding underneath the ocean, but they're not manifesting on the surface at all. It's only when they hit Ecuador, which is right there, and whoa, look at that. Nice cooking warm temperatures. All right, so Chile, Peru, Ecuador, the Galapagos right there, the equator here, and California up here. And here is our high pressure. That's the center of the North Pacific high pressure system with dead air, so temperatures warm up there. Here's the leading edge and the massive upwelling response along the California coast and down into Baja. And then here's the building warm pattern here. Now, it looks maybe not quite as warm as last week. No big surprise. I mean, it couldn't get any warmer. And that Kelvin wave number 1 has been erupting for a while, but you also see clearly warm water from that Kelvin wave being caught by the trades and dragged off to 140, maybe even as far as 150 west, and then just warming the whole way across the Pacific. This whole area was, for 3 years, just a freezing cold upwelling mess. Now we've gone the exact opposite direction. Sea surface temperature trend for the past 7 days. So South America here, Chile, Peru, Ecuador, the Galapagos, and Hawaii out here, but it's the equator right here. Now, you go, temperatures are, the blue means they're cooling. Yes, temperatures are cooling here a little bit because Kelvin wave number 1 has pretty much, it's as hot as it can get. It's erupted. It's moderating some. We know there's another Kelvin wave literally right here at 100 west underneath the ocean surface. All this, now notice there's warming pretty much from Ecuador the whole way across the Pacific, but all this is a mixture of surface warming from westerly anomalies out in here and decreased easterly anomalies because of the active phase pattern pushing across the Pacific. Trades are weaker than normal, less upwelling, temperatures start warming, if nothing else, just by the sun cooking the ocean surface. Now we expect, I don't know what it'll be. If the leading edge of Kelvin wave number 2 is here, it'll probably take another 3 weeks maybe to make it into here, but we'll expect this is all going to light up again. Now remember, trades are taking these warm waters here, pushing them across, and that is also explaining why we have warming out here. If you get another big flare-up, multi-month-long flare-up of much warming waters here, and that all gets drug across here, that will just help feed El Nino development all the more. And then the backed-off view here again. Now, one other thing that some of our viewers have noted. Now, here's the warming, the typical El Nino triangle like that, right? But you go, but wait a minute, look at the Atlantic. It's all warm. And look at the South America. And look, I mean, the whole planet's just cooking. And I'm not trying to stir up a hornet's nest here, but NOAA has been saying for years, the oceans are getting warmer due to whatever you want to believe it is. And I'm trying to be respectful of everyone's opinions here. But there are clear signs in all the satellite data. And if you go back, and we'll do a little look at this in just a second, and we're not going to go a deep dive in it, but you can see this just typical pattern of the atmosphere or the oceans warming as there's more heat in the atmosphere. The ocean is like a sponge. It sucks it up, which is a good thing, but at some point it won't be able to suck it up forever. Sea surface temperature index in the Nino 1.2 region. This is the area right there by the Galapagos and Ecuador. Temperatures, well, remember, we just saw that the trend is temperatures going down a little bit. Okay, today's value, plus 2.262, right there. We were up at almost, I think we were like at plus 2.96 at one point right in here. So warming, the El Nino threshold, and it really doesn't apply in the Nino 1.2 regions, anywhere from neutral is half a degree below normal to half a degree above normal. Anything above half a degree above normal is El Nino-ish if it goes on for we'll say 5 consecutive months. It's really longer than that. Okay, but then the Nino 3.4 index. This is the official El Nino monitoring region. It's just 5 degrees north and south of the equator from a point south of California out to about the dateline. Today's value, 175 thousandths of a degree above normal. So not really that warm. In fact, the Nino 1.2 area is just right here, right where all that bright red is, so no wonder it's lit up. The Nino 3.4 region is from here out to here, 5 degrees north and south. And yes, things are warming up, but this light yellow is, maybe half a degree? So we're getting there slowly. And again, the quick look, the Nino 3.4 index, 175 thousandths of a degree. What we said earlier to be neutral, anywhere from a half degree below normal to half degree above. El Nino starts at half a degree above normal or more for 5 consecutive months. So we're nowhere near there. We're officially, according to this, neutral, which means that's a really good thing because it takes a lot of momentum just to get the ocean. I mean, we were sitting down at -1 or 1.5 for 3 years. To get to here takes a lot of energy being transferred around the Equatorial Pacific to get us here. But once the boat starts turning, it gets momentum and it's really hard to stop. And we think that's where we're headed. Next up, what does the atmosphere think is going on, okay? We know there's this MJO stuff that's going on that's creating these Kelvin wave things that's pushing warm water across the Pacific, that's erupting off of Ecuador and the Galapagos, and then is getting caught by the trades and starting to get pushed off back across the Pacific. That should start some sort of a feedback loop. That is, the atmosphere should go, well, I got all this warm water and it's lifting. That should theoretically lower pressure in the Pacific. All right. So we look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. All right. Tahiti is in the Pacific, Darwin roughly in the Indian Ocean. When pressure is lower in Tahiti, the index goes negative. Hey, we're at minus 16.44. Look at this. Wait. We've been negative or darn near negative since mid-April or more. Then going back in time, well, hey, we've been doing pretty good. If you recall, when we were in La Nina, we were at plus 20 and just pegged there for 3 years. Things are changing. The 30-day average takes some of the noise out of these numbers. It, too, is saying, well, we're down at minus 2.25. That's a good thing. And we've been, yeah, I mean, this is sort of the active-inactive phase of the MJO tracker, but the trend is definitely downward. The 90-day average is, well, it's still positive, 3.03, but where were we? Well, we were at 8.52. So all these indicators are heading in the right direction, suggesting warm water building in the Pacific. That in turn is creating more evaporation, lifting in the atmosphere, lowering pressure in the Pacific. And then we know from our models that the low pressure bias is sitting over the date line. And so everything now is sort of moving in the same direction. We have momentum towards El Nino. We are not in El Nino right now, but all this is foundational work. And then the manifestation of El Nino is just the icing on the cake. It won't really start showing till maybe a couple months from now. Forgot to show this earlier, but I'm going to show it now. This is the sea surface temperature trend since, I moved myself out of the way, January 1st of this year, 2023. All right, so here is our La Nina. Oh, let's get ourselves oriented. Chile, Peru, Ecuador, South America, Hawaii, equator right there. Dateline right there. This is the classic La Nina signal. The blues, colder than normal temperatures. You see it on the scale down here. La Nina in control. And we're just going to pick through this, boom, boom, as we get into January 15th to 22nd. January 29th. Hey, warm water starting to build here. And the La Nina signal pushing off to the west, getting caught by the trades. It continues in February 12th, February 19th. Oh, then there's... Now you would go, what's this? Well, this is, we think, just winds that typically seasonally start blowing in the Gulf of Mexico. They just blow down through this strait, create some local upwelling. Nothing to be too concerned with. In a week, boom, it's gone. And then March 12th, our warming signal building, warm water pushing out across to the west. It sort of fades, it stalled a little bit. Notice the upwelling pattern along California as well. And then getting deeper as we get into April 1st off California. But notice, let's just go back. We went from, yes, warming in 2 weeks to cooking along Peru and Ecuador, and the upwelling pattern here building April 8th, then holding April 15th, while last week it was just, I think that was the peak of this upwelling phase. Warm water pushing out, and then we'll go one more. Okay, and that's today's image. So let's just go back we're going to do this a couple of different ways. February 12th, keep your eyes here just to see the upwelling pattern, and keep your eyes here to see the warm water eruption pattern, and then keep your eyes here to see the capture of those warm waters by the trades pushing off to the east. Just do this a little bit at a time. And there you go. And notice all the La Nina cold waters are out here completely gone. So, hangover of La Nina, still evident. El Nino building, but not officially in El Nino status yet. All the fundamentals in place, and the machine keeps going. Now let's do one more comparison. Now this was the same time, April 22nd, I'm going to do it like that, April 22nd, 1997. And that little bit I was talking about the oceans getting warmer. We'll look here, look here, look here. I mean, this is more of a balanced view. And even then, it was warmer than normal on average. And now let's go take a look at where we are now. There you go. And we'll go back one more time from there to this. Now, what do we see? Well, we see, for one, the current warming in the El Nino regions is much stronger than it was back in the major El Nino of 1997. That was a super El Nino. So this year's version is much stronger than what 97 was at this point in the game. We'll see if that continues. It doesn't necessarily mean anything, but it does have many climatologists and meteorologists pretty concerned that the developing El Nino of this year is much stronger, much earlier in the game, which could likely result in a much stronger El Nino and impacts into California and Hawaii and the Pacific Ocean when it matures in November. In 97, the impacts were extreme, so we were very mindful of what could potentially happen as we get into winter of 2023-24. And then there's also this whole bit, this signal of the oceans just being, in general, warmer, too. And you can see it between these two images here. All right, let's move on. And I forgot to show this earlier, but just the 30-day moving SOI graphed out. Downward spikes are the active phase of the MJO. Upward spikes are the inactive phase. This goes back to January 2021. You can just see as La Nina was building the steady upward trend in the Southern Oscillation Index. And then it held into about January 2023. And look where we are. We're just on this steady crashing thing. We would expect to see this down around minus 15 as we get into September, something like that. And then finally, sea surface temperature projections for the Nino 3.4 region, the official El Nino monitoring region from the CFS version 2 model. You can see, well, let's see, where are we? We're in April. This is mid-April right here. So we're right about here. This says temperatures are, well, it says about, we'll say 0.2 of a degree above normal. And the data we just saw from the previous data set said we're 1.25 of a degree above normal. But there's a little bit of variation between all that. Anyway, as we get into July, now this is the raw data. And remember, the El Nino threshold is 0.5 degree above normal. So this says by April, probably by sometime in late May, we should be in El Nino official territory. By July, we should be up to plus 1.45 degrees. Now, this is the raw data. It tends to overhype it a little bit. And then as you get into November, we should be at 0.25 or 0.255 degrees. The last big El Nino was only got to plus 2.3 degrees. So this theoretically stronger than that. But again, this is the raw data. Let's go back to the PDF corrected. Maybe it overcorrects it a little bit more conservative view. Anyway, transitioning to El Nino in April, May, June. Yeah, sometime in late May, early June, something like that. And then by July at plus 1.2 to 1.25 degrees. And then getting into November, October, November at 1.95 to almost 2 degrees. Either way you slice it, that's a pretty solid El Nino. Now, the CFS model here is a little bit on the high side compared to a whole bunch of other models. But the flip side is, I believe it's more accurate than a whole bunch of those other models too. So we'll see how this plays out. All indications are a major El Nino is developing. So for right now, hey, looks like there's some surf on the way coming from the south. Little pulse for later in the week for California. Not so much for Hawaii, but Hawaii has a little bit of north swell for right now. Another theoretical pulse of southern hemiswell developing as we get into the Thursday, Friday time frame with about a week's travel time up to Hawaii and maybe 8 or 9 days into California. And then multiple other systems, at least forecast, trying to organize around the edges more than a week out. We'll see what really happens, but it looks like the change of season is really happening. We do need that north wind upwelling pattern on California to really settle down, but I think we're going to be stuck with it for at least another month. So suffer and try to make the best of it and hope for better things to come there. The other news, though, is, of course, the development of El Nino. All systems pegged to the red, all moving forward. El Nino is developing. I think our next major checkpoint will be sometime in mid to late May, when the next big active phase of the MJO sets up. Then we'll see how strong westerly anomalies blow and how much of yet more Kelvin waves are generated. So think about it. If El Nino is peaking in the November time frame, so what's that be, like August, 3 months for a Kelvin wave to get across the Pacific, so August to September, October, November. Yeah, so sometime in mid-August, there should be at least one more big active phase of the MJO to create yet another Kelvin wave, and that's at a bare minimum. The suspicion is there will be active phases pushing the whole way through into probably January or February of next year. Then the whole thing will collapse, and we won't even talk about what's coming after that, but none of it is good in terms of surf or rain, at least not immediately, but we'll see how this all plays out. But for right now, lots of good news, lots of hope on the way. We just need the El Nino pattern to get a little bit more established and wipe out the last of La Nina from the atmosphere. Then we're off to the races. All right, that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.